This morning I thought we'd have a look at electricity, given that it's sort of core to everything and now people are starting to drive electric cars a little bit more. It helps to know something about it. I never used to know much about it until until I got into solar panels, ironically. But that's another story for another day. Just one quick caveat. I am not in any way an expert on electricity. I just have a working understanding of it that I have gained through the years as I've used it for various different projects, like building my solar generator, the portable version, and building my non-portable solar generator. And that's basically where I learned what I do know about electricity, and it's more of a working knowledge than a 100% rock solid science-based knowledge. But ultimately that's what most people need, just a good working knowledge of roughly what electricity is and how it works and how to use it and things like that. To aid us in our attempt to get to grips with the elusive power of electricity, we're going to use my trusty whiteboard. I'm not actually sure what the best way to do this is, so I think what we'll do is we will just have a go. What's the worst that can happen? Right. So, the first thing we need to understand, and this is really important, is there's one basic equation. This is the only equation I'm going to use at all. And that is that watts equals volts times amps. Now in general terms, this voltage that I like to describe as pushiness, the reason I call it pushiness is as the voltage increases, the ability of electricity to overcome resistance increases. So for example, if you've got dry fingers, you can touch both terminals on a 12-volt battery and it doesn't matter how much current is there. It just doesn't have the pushiness, the pressure to actually overcome the resistance in your skin and form a circuit so that electricity flows from the positive to the negative. So you won't get electrocuted. But if I made that 120 volts, but much less ampage, then the electricity would be very pushy, but it wouldn't have a lot of oomph behind it. But you would get an electric shock from that, which is why tasers have got tiny current at like 50,000 volts, because that way the electricity is just going to cross virtually anything, any material that comes between those two contacts, and it's going to make its way through and give you a zap. But they don't put a lot of current there, so it doesn't kill you, of course, in theory. The more current, the more resistance, and the more resistance there is, the more heat is going to come out of it. So that's why it's more efficient for electricity to be transported at a high voltage and a lower current, because the higher the current, the more energy will be lost as heat. That's why the big power cables that run around the country, the big power pylons, they're all running at sort of 240,000 volts, or probably even higher. Whereas what's in your house runs at 240 volts, and what starts your car is at 12 volts. But the voltage says nothing about how much actual energy is in that power. It just says how desperate that energy is to sort of make a circuit. So how does this work then with circuits? Well, you've got do a bit more drawing, you've got your battery with two little bits come out of there, a positive and a negative. And like this, the power flows round and the light comes on. This is called DC power, direct current, because the current is just flowing in a direct circle around the loop. It's also very inefficient, which is why a guy called Nikola Tesla sort of connection there with the older Tesla motors, invented something called alternating current. And alternating current is where, rather than this model of a circuit, what you've got is the power, rather than being positive and negative, you've got neutral and then a live, and the live goes from positive to negative to positive to negative. And unless you've got a rubbish inverter, it doesn't do that in large steps. What it does is it does it in something called a sine wave. So it goes up and down and up and down and up and down. That is the worst sine wave ever. I can't live with that. Let's have another go. Another point just quickly. The rate at which this current, the voltage moves from positive to negative gives you the hertz, the frequency of the AC. So you may have seen on devices, it says 50,000 hertz to 60,000 hertz or something like that, usually on the power adapter for your laptop, for example. And that sort of varies country by country. I think the UK is 50,000 hertz generally, and the US is 60,000 hertz. And that means that 60,000 times or 50,000 times a second, the electricity moves from positive to negative. And because the power does that, going sort of positive, negative, positive, negative, positive, negative, it means that the electrons are just moving backwards and forwards, backwards and forwards, backwards and forwards, backwards and forwards in the same piece of metal, and it substantially reduces the amount of energy that's lost. So that's why power is transmitted around the place in alternating current. But with almost, well, very, very few exceptions, like maybe an incandescent light bulb, that uses alternating current, but most devices will convert alternating current to direct current in order to then use them. AC induction motors, like you find in most modern electric cars, they also require alternating current. However, the batteries in those cars are direct current because all batteries produce direct current. So what actually is a battery? Well, a battery is a series of cells. So if we look at this battery here, this could actually be made up of 4 different cells. And there's 2 different ways to connect these cells, because they've each got a positive, they've each got a negative. You can connect them in series, which is where you've got negative. If you do that, then the current stays the same. So whatever the max current that this could supply was, so if it was 3.2 amp hours, it would still be 3.2 amp hours. But if the voltage was originally 12 volts, it would have now gone up to 24, 36, 48. And the other way to connect up batteries is to do them in parallel. If you do that, sorry about the horrific diagram here, but if you've got all the positives connected together and all the negatives connected together like that, then what happens is the current gets added up. So if it was 3.2, it would then be 6.4, 12.8. So this would be 12.8 amp hours, but it would still just be the 12 volts. And that's worth knowing, because that's, with electric car batteries, they build up the voltage using cells that are just 3.6 volts nominally. And what they do is they put those all in series until they get the voltage up to about 400, and they call that a sort of a module or whatever. And then they put lots of those in parallel to build up the amps, so that they've got the amp hours, so that they've got the current and the voltage that's necessary to actually drive the vehicle in an efficient way. Which is why those milk floats, the old sort of milk floats, were awful. Well, actually the main reason they were awful is because the batteries were awful. We'll get to that in a future episode. Anyway, I think that covers most of the basics of electricity, sort of a real beginner's guide. But it's worth knowing, so when you see, you know, if you want to plug in an electric car or something and it says this is 7 kilowatts, that's the power, that's the that's how much work it can do. And because the voltage on that will be 240 volts, the amps on 7 kilowatts will be 32, because 32 amps times 240 gives you not exactly 7 kilowatts, but close enough that there's no real difference. I hope you've all found this to be an interesting post. Electricity can be a bit dry, no pun intended, but it is also something that is all around us and becoming an increasingly important part of all the technology we use, thanks to the sort of rise of batteries. And I mean, battery technology is amazing, and that is another subject which on the surface seems relatively simple, but then quickly gets ludicrously complicated. But we'll cover that off on another day, after we've done something more light-hearted tomorrow, I think. Anyway, bye. Remember to subscribe, and that way you won't miss out on all the fun and entertaining things that are going to be happening in the very near future. Anyway, bye. You know, it's calm enough and sunny enough, I might actually go for a fly today. That'd be good. Haven't been for a fly for ages.